I'm calling this YouTube channel On Shoulders because I want to emphasize the fact that all of the stuff that I do, the 3D printing, the robotics, would not be possible without all the people working in this community. So I just want to take a moment to thank you, to thank the people who are working in the RepRap, to thank the MakerBot operators, and all of the people with robotics as a hobby that are working in that community. Thank you for being amazing. Today's episode is about the electronics of the Dogbot. And the electronics really center around the RINO, which is an open source project. And my variant of choice is called a board RINO. It's an Arduino clone that snaps into a breadboard like this. And the two reasons I like this board is because it's really cheap. It's about $17. So I like the fact that it's cheap. But I also really like the fact that it snaps into a breadboard, and I prefer to do my prototyping on a breadboard. So this board allows me to just grab some wires and really make any circuit that I want for $17. The only drawback that I've found with this board is that you need an FTDI cable, and these run about 20 bucks. But all you need is one, and you can plug into any board. So in the end, it ends up saving you money. The other option would be to get a board RINO that has a USB port. But the problem with that board is it's a little bit more expensive, but it also doesn't have a DC input. This board, I could just plug it into a 9-volt battery and run it on the 9-volt battery, or I could power it through the FTDI cable. The USB version doesn't have that option. So to get us started, let me make sure that I'm lining up black with black and green with green. All right. To get us started, I'm going to go ahead and plug this in, and we're just going to upload the Blink application, which comes standard with the Arduino development environment. And I've got to select the right pin. There we go. Okay, so we see that it's on because the green light is on. But right now the red light is not doing anything, it's just there. So we're going to upload the Blink application. So let's go over to the computer. Okay. So we're just going to open the Arduino development environment, and we're going to use a provided sketch called Blink. So if you have the Arduino development environment, you already have this sketch. And I like to start with this sketch because it's really simple. All it does is declares pin 13 as the LED pin, declares it as output, turns it on, waits a second, turns it off, and waits a second. So just to make sure we're hitting the board, I'm going to change this to 2 seconds. Turn it on for 2, turn it off for 2. I'm going to verify that it can compile, and I'm going to upload. Uploading to board. And we see that the red LED pin is turning on for 2 seconds and off for 2 seconds, on for 2 seconds and off for 2 seconds. Now surprisingly, going from a simple application like Blink to a more advanced application that uses servos is not that hard. So here's a hobby servo, and all you really need to know about a hobby servo is this particular one has 90 degrees of freedom. So the shaft can rotate from 0 degrees all the way to 90 degrees and back. It has 3 wires. Red is positive. In this case, brown is negative, but sometimes it'll be black. And in this case, orange is the data lead, but sometimes you'll see it as yellow. So what we're going to do is plug this servo into our board RINO, and I'm going to plug the data lead into, let's go with pin 7. And I'm going to plug the positive lead into a positive terminal, not the board. I'm not plugging the positive lead into the board, into the Arduino. I'm plugging it into a bus on the breadboard that's currently not plugged into the board. And I'm going to plug the negative lead of the servo into the negative bus of the breadboard. Okay. And now I will connect the negative bus to ground. Negative bus to ground. Okay. And in order to supply power to the servo, I'm going to use a completely separate power supply. I'm not going to be using the power supply from the board. I'm going to be using a 5-volt power source that's coming from a computer power supply that I hacked for this purpose, just for playing around. And the reason I'm not using the 5 volts that is being supplied to the board is because that voltage is coming from the computer through the USB, and it's not strong enough to power a servo. So right now these 5 volts are not live. It's currently off. So I'm just going to apply what will be 5 volts from a power supply to the 5-volt bus that's currently only hooked up to the servo. And I'm being so clear here and saying everything twice because I get these things wrong all the time, and it's not pretty when you get things wrong. You end up ruining your equipment. All right, and now I'm applying the negative, the grounds from the power supply to the negative bus, to the grounded bus. Okay. So we now have a servo wired up, and just to make it very visual, I'm going to plug a piece of the dog leg on the servo. And now I'm ready to go back to the computer and write a little bit of code. So the first thing we're going to do is declare a pin for the servo. So we'll just say S1. And we know it's pin 7 because we plugged it into pin 7. And now we're going to declare it as output. Output. And we're going to use it in the loop down here. We're not going to use the LED pin anymore. So let's get rid of that. And what I basically want to do is I want to say for 100 times, tell my servo that I want to go to 180 degrees. Now, it's actually the range of motion is 0 to 180 degrees. So the way that I say 180 for a servo is to send a pulse. And the pulse is measured in microseconds. and I know that 2,500 microseconds, a pulse of that length, is telling the servo to go to 180 degrees. So I'm going to tell it to go to 180 degrees, but I don't want to constantly say go, 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 because it'll make the servo hot and it's unnecessary. So I'm going to tell it to go to 180 degrees every 20 milliseconds. So every 20 milliseconds, go to 180 degrees. Go to that position. And if that's all I say, then it'll just go to 180 degrees, and that's it. But I want a little variety. I want it to go from 180 degrees to 0 degrees. And I would normally simply say 500, delay for 500 milliseconds, because on average that is the position 0 for a hobby servo. But I know from experience that the hobby servos that I'm currently using freak out when I tell it to go to exactly 0. So I'm going to say go to 600, which is like go to 3 degrees. So again, go to 180, go to 0. Go to 180, go to 0. And do it for 100 times 20, or 2 seconds. So go to 180 degrees for 2 seconds, and then go to 0 degrees for 2 seconds. It really is that simple. So let's compile to make sure it's working, and let's upload. So we're uploading to the board. And we see that the light is no longer blinking. So that's a good sign, but the servo is not moving. Now my guess about the servo is that I haven't turned on the power source yet. So let me turn on the power source. There we go. And we see that it's going from 0 degrees to 180 degrees every 2 seconds. I'm going to turn it off. Sorry. Okay. So stay tuned for the next episode, where we will get even closer to finishing this Dogbot.